Hello friends, welcome to C# Intermediate to Advanced tutorial. In this sub-series, we have been watching C# reflection method call. So in this video, we will see how to call a static method from our class library, which we already created in the first part of the video. So here, we will be invoking a static method from a class via reflection. So first we created a DLL, and that DLL exposes two methods for experiment purpose. One is a static method and another one is a normal member function. Next, we talked about the flow, how we will invoke a static method and how we will invoke the member function. And then we talked about the example as well. So this is the method we are going to invoke. I just displayed it on the side. So you can see the method is static. Method name is add numbers. There are two parameters, so the type collection will have two entries. Both are same type, integer and integer. Then there are two values required to use this add number function or to make a call to this add numbers function. Since it's a static, we no need to create an instance. We can directly make a call to this method. So to use reflection, we need to include the namespace system.reflection. Then in the add button click, we know that our form contains two buttons. Very first button will make a call to the static method. So that's the button here, btn add click event. And if you see, we are making call to assembly.LoadFile. Here we specify location of our assembly. That means when we build the project, it will deliver the DLL to some location, and we are copying that to the E drive temp. So that means in E temp we will be having only the DLL, and that DLL contains the class, and that class exposes functionality in terms of methods. So here, using the load file, if you see, we are loading the assembly at runtime, and reference we are storing it in ASM. So the return type is also assembly. The load file is a static method. That's why we are directly making call to load file from the assembly. So it returns an assembly instance, and that instance denotes this DLL assembly. Next, to retrieve a specific type from that DLL assembly. At present, our DLL assembly contains only one class, and that class is simple math. So here we are giving the fully qualified name. That means delay load DLL, then simple math. So this is our namespace. Inside this namespace, there is a class called simple math. And we already have the loaded assembly from this ASM. We are making call to get type. So here we are getting the type. This time the type is simple math. So get type returns an instance of a type. We store that here in CLS. Remember, our goal is to make a call to this static method, and this static method requires two parameters, and since it requires parameter and we are doing everything at runtime, we need to specify the type of the parameter. And here if you see, we are creating the type array. So the slat contains two entries, argument of 0 type of integer, argument of 1 type of integer. That means here we specified type for our method. First one is integer type, and second parameter also integer type. That's what here we are denoting. And then if you see, we are making call to the get method. Method name, we are telling it as add numbers. Then parameter type, we are passing our argument array, and the argument array tells int. That means here we specified the argument type. So this will be useful when your class exposes overloaded methods. So overloaded method means even though you have add numbers overloaded version, that means add number that takes 2 integer parameter, add numbers that takes 3 integer parameter, add numbers that takes 2 float parameter. If you see, method name is same, but they differ based on the parameter type or order of the parameter. So here, the same way, you have to specify your type. And in our case, both are integer. If the argument list is like float integer, then you have to create it in the same order. The first slot should have float, second slot should have integer. So when you are asking for get method, it will perform the method name as well as argument match. Based on that, it will pick the correct method exposed by the DLL, whatever you got here. So DLL loaded into assembly. We have the assembly. From assembly, we are getting the type, because a DLL can expose multiple classes, right? So from the DLL, we specified what class we want to use. So using get type, we retrieved the class type. We have class. From class, we are using the get method. When you use get method, name itself not sufficient. Why? Because there is a possibility of method overloading. So we specify our argument type. So this will correctly pick the method. Once you have a method in hand, you can store that using the method info. So get method returns a method info. Now we have static add method in hand. Alright, we have add numbers in hand. That means we are pointing to this method, but to make a call to this method, we need to supply parameter values, right? So if you see, for that, we are creating one more array. This one is the type array. Here we are creating the object array. So through reflection, we can use object array. Why? Because it can match to any parameter type, whether it is integer, float, string. So you can use object array. Here, argument value. So the array name is arg value. So arg value of 0. Int.parse, we are taking the input from our form. Txt number1.text, and we are parsing it as integer, and we are placing that in the slot which we already created. So whatever this one supplies, that will sit here, that will match to the type array which we already created, right? This one and value supplied, these two should match. Then we are supplying txt number2.txt to, and we are filling the second slot as well. Now we have everything is ready. We specified, we retrieved the correct method, and to make a call to that method, we need to supply two values to it. Why? Because it expects integer 1 and integer 2. And using the object array, we supplied that value. And when we are supplying the value, we are taking the input from the form and parsing that as an integer. Since it's a object array, it will hold the integer value. And here actually a boxing will happen. And boxing and unboxing I can cover quickly. So integer is a primitive type, and if you want to use it as a object, that will be called as a boxing. Primitive to object type, this is unboxing, from object type to integer. Alright, here we filled our object array. Now it's time to make a call to the method. If you see method info, we already retrieved the method by passing the method name and the correct parameter list. Correct parameter in the sense correct type and in correct order. So we retrieved the method info. Then this is the static method, right? A, and we use that static method and make a call to invoke. For the invoke, first parameter is null because object is not required here. Since it's a static method, we are passing null. Then argument value, if you see, we already have the arg value and we are passing that here. The populated argument, we are passing that here. So where is the type information? Type information is already available here in the static add method itself. Get method, we retrieved the correct method. So that's all. Here the argument value itself sufficient. Why? Because we have correct method in hand. So this type information is to pick the correct method from the exposed from the class exposed method. If it has multiple method with the same name, so the argument will list to retrieve the correct method. Once method is in hand, then we just need the argument value. That's what we are doing. So method info dot invoke, and we are passing the value, and now we know that this will make a call to our method and it returns a value. And return value, if you see, once again we are storing it as a object. Then we need to display this result in our multi-line text box, right? That's what we are doing next. Text info, append text. So this is the result, and if you see, we are directly concatenating with the string. So this will internally perform the toString and convert the value and displays the result. Environment.new line is to call the method multiple times and display the result in a new line. Alright, here if you see, first sequence 1, load the DLL, sequence 2, method, class, sequence 3, method, sequence 4 is calling the method. That's all we need. So if you see S1, loads the assembly. So a system may have multiple assembly, right? You can load any assembly, whether it is a DLL or exe, you can load the assembly. Once a sequence 1 is completed, you can go for sequence 2. In sequence 2, you will be picking the type. So what class you want, that you can retrieve, sequence 2. And sequence 3, if you see, once you have type in hand, that means class in hand, a class may expose many methods in it, right? So you either go and instantiate the object, or you will pick the specific method that you want to call. So here in this sequence, since it's a static method invoke, we can say here in sequence 3 we got a method, and to pick a correct method we need this argument type. That's what we did. Then finally we make a call to the method, and since this requires parameters, in our case parameter value, we found those parameter value and passed that. So that's all the sequence in static method invocation. Load assembly, get the type, get the method, then make a call. Here if you see, no constructor involved. That means we are not constructing the object. We are loading, we are getting the type, we are making call to the method. In normal flow also we will do the same, right? We will specify the class name, then we will specify the method name. After that we specify parameter and make a call. So that's why this sequence doesn't involve creating the instance. Alright, now we will go to the demo. It's demo time. Okay, this is our project. Now we will build the solution once again. And if you see, this is delivering the DLL, right? We will copy this path. We will place it in some convenient location. So I'm pasting that DLL in eDrive temp. You can have that DLL anywhere you want. Here I placed this in eDrive temp. Now we will proceed with the example. So for now I will auto hide this. So we will handle the click event of this first button. So to use reflection, we need to include the namespace system.reflection. Next, in the button click event, if you see, we already copied the DLL to the eDrive temp location, and we are loading the DLL from that specific location. And we have that DLL in the assembly. So let me expand our exe project. This is the exe project, right? Delay load DLL is the DLL project. This one is the exe project which exposes our form. And I'm in Solution Explorer right now. In the reference, if you see, we are not making a reference to this delay load DLL. That means we are not making any static or binding at the compilation time. The binding will happen at runtime. Here, if you see, there's a specific call loads the DLL in the context of exe. So we will keep a breakpoint here and we will check that. Let me run it. We will clear this. So clicking on invoke static. This is a different DLL configuration. Now when I execute this specific line, load file, you can see delay load exe, which means the exe which contains this form or our Windows form application loaded the assembly at eTemp location, which is nothing but our delay load DLL. So we are loading it at runtime. Once the assembly is loaded, then we can make a call to the methods or functionality exposed by it. So this DLL contains a namespace and it contains a type simple math. So the project may contain multiple classes also. Here we just took one specific class, simple math, and we are going to invoke add number static method in this video, right? And in the next line, if you see, once the assembly is loaded and we have that in hand, then we can make a call to assembly.getType delay load DLL. This is the namespace that exposes simple math. So we specified this. That means we are asking to get that specific type. That means the class type simple math. So simple math is here in CLS. Next, our goal is to pick this static method, and here we have only one method under the name add numbers. but there is a possibility that a simple math can expose overloaded version of add numbers. Add numbers, that is taking one integer parameter or two integer parameter or three integer parameter or two parameter, but one is integer, another one is float, or first one is float, second one is integer. So there may be multiple combinations. So specifying the method name alone is not sufficient to pick a method exposed by a class. So that's why what we do, we specify the type array. And here, if you see, now we know the namespace, we know the method, we know the method name add numbers, we know the args types as well to integer. That means it will perfectly pick this specific add numbers. From type, we picked the add number method and we are holding that here in the method info. Name is a static add method. That's all. Once method name is in hand, you can create a object array because we need two value. So we created array of object with a two slot in it. Then we are passing our content txt number 1, txt number 2 dot text, parsing it as integer, then putting those two content into the argument value. Then since we already have the static method in hand, we are specifying that and making call to invoke. You see, it invokes the method. First parameter is null. This is an indication that we haven't created any object. We are accessing the static method. So we pass our argument value, which is specified through these two text boxes. All right. Now this will make a call to the add number here, and we print the result in the debug window here, as well as the result is returned to the caller. So the caller here is our exe. That's all. Then we print the content here. So what we will do, we will keep a breakpoint. So for this breakpoint to work, okay, symbol loaded, that means no issue. Breakpoint will hit. So same, I'm specifying 12 add, and here you are seeing add number method is invoked, right? And here you will be seeing added result is 24 in the console window as well as in the output. And if you see, our exe is not making any static binding, but it loaded the DLL. I can say it loaded the assembly, then it asked for a specific class type, and from that class type we returned a specific method. Then we called that specific method with a required value and printed the result. So just now you saw the demo. We invoked a static method, and in the next video we will invoke a member method. Thank you for watching. Bye.